Hey guys, good morning. So we are going to go through the information that we talked about in our live Zoom today. So I do have two screens, so I'm going to be looking at the one that I'm writing on, but we are going to be doing systems of equations, word problem introduction today. So let's think back and recall. So systems of equations means two equations, or technically really more than one, but in math one we're focusing on two. And we're going to be doing an introduction today. So remembering how to solve the systems of the equations, you can do substitution or elimination to solve. And then today is just going to be an introduction into that. So we did a little breakout rooms today and a Jamboard in our Zoom. So if you are not joining our Zoom, you should come check them out because I put you all in the rooms to do work. You all can talk, have fun as you are completing your assignment during the Zoom particular class. So what we are doing, the steps that I had laid out for the students today was to read the problem, determine what pieces of information is in the word problem, create an equation for each system of equation word problems, state what your variables represent, and then work with a group, or you need to work by yourself now to solve using either substitution or elimination. So let's go ahead and get started. So I'm going to look at this particular problem, and we need to determine, based on those steps, what is this problem talking about? So as I read, there are 4 animals in the field. Some are pigs, some are ducks. There are 12 legs in all. How many of each animal are in the field? So we need to pick out the 2 pieces of information that is given to us. So I know or what the word problem is talking about. So I know that we're talking about 4 animals. And they're also talking about legs. So there are 12 legs in all. Okay, so we have 2 equations that we need to represent. So it's an animal equation and a legs equation. Okay, so let's take a look at the animals. So how many animals are there in all? That's going to be your total. That's going to be what your equation is equal to. In this case, we had 4 animals. And what animals do we have in our particular problem? We had pigs and ducks. It didn't tell us how many, so those are unknown information. So we need to use a variable. I'm going to use P for pigs and D for ducks. Okay, now for the legs, there are 12 legs in all. And use some knowledge. 4 legs are on a pig and 2 legs are on a duck. Okay, so we have our 2 equations. Now we need to solve. So if you think back to systems of equations, whenever we were solving with algebra or algebraically, we were using either substitution or the process of elimination. So I noticed that I don't have a variable that it's isolated, meaning it doesn't say P equals or D equals. It has P plus D equals 4, and 4P plus 2D is equal to 12. So it's going to be easier, just personally for me, and this is my preference, if we use elimination. So let's go ahead and eliminate a variable. So I'm looking at 4P. Yes, in the Zoom class today, I eliminated the ducks. And if I need to eliminate this, I need to look at the coefficient in front of that variable, which is the number. The number is 4. So I want 4P to also be on the other equation so I can eliminate that. Now we're going to use the distributive property. Okay, so that becomes 4P plus 4D is equal to 16. Do not forget to multiply by that last number as well. Okay, then everything stays the same on the second equation. 4P plus 2D is equal to 12. And now, in order to eliminate, we need to decide whether we are adding or subtracting. So I wanted to eliminate the P's. Okay, so if I was to add, that would be 4 plus 4, and that's 8. That's not eliminating anything. We need it to be 0. 4 minus 4, though, is 0. So let's go ahead and subtract our equations. So 4 minus 2 is 2D, and 16 minus 12 is 4. Okay, so as I divide by 2 on each side, D is equal to 2. So there were 2 ducks. Okay, and we had a total of 4 animals. So that means that there also has to be 4 pigs. 2 pigs, because 2 plus 2 is equal to 4. Okay, let's go ahead and do another one. Let me erase it all. Okay, now this next one, same concept. So we are talking about animals in a barn and their legs again. So we have 24 animals. And we're talking about geese and sheep. So I'm going to use G for geese and S for sheep. And that equals 24 total animals. Okay, then I also know that geese have 2 legs, sheep have 4 legs, and there are a total of 86 legs in this problem. Okay, so let's go ahead and use process of elimination again because I don't have an equation that solves for a variable or a variable that is isolated. And let's just go ahead and stick with eliminating the first one. Again, if you wanted to eliminate the sheep, you're more than welcome to. So in order to do that, I want my top coefficient for the geese to also be 2. So it looks like 2 times G, 2 times S, and 2 times 24. So that's 2G plus 2S is equal to 48. And then that bottom one is going to stay the same. 2G plus 4S is equal to 86. Okay, now we need to decide, do I add or do I subtract? So if you go ahead and look at the G's, you see 2G minus 2G. So it's G, 2G and 2G. In order for it to be 0, we're going to need to subtract. So we have 2 minus 2, that cancels. 2 minus 4 is negative 2S. And then 48 minus 86 is equal to negative 38. Now, don't freak out about the negatives. Of course, an animal cannot have 0 or a negative amount of legs. But if I divide by a negative divided by a negative will give me a positive. So it ends up working out. So sheep is equal to 19. And how many animals in all were there? There was 24. So if I do 24 minus 19, I'm getting 5. So we had 19 sheep and 5 geese, which makes a total, geese is 5 geese, which makes a total of 24 animals. Okay, bear with me. I have one more example to share with you that are not dealing with animals and legs, just in case we need another example as we dive into those word problems today. Okay, so let's look at an amusement park. So for this one, or I'm trying to see which one has more room to write on. None of those. Okay, so we'll go back and let's look at the amusement park. So we have Kimberly Rain Amusement Park with the large animals. Really animals again? She charged $20 for horse rides and $50 for elephant rides. 55 rides were offered and $2,000 was collected. So as I read this problem, and again, you might want to use the 3-read strategy. So which is you're reading it 3 times, what information is given, what operations are included, and then how are you going to go about solving. So as I'm looking and I'm reading through this, we know she's going to an amusement park with large animals. She is charged a particular amount for horse rides, for elephant. 55 rides were offered and $2,000 was collected. So my particular information that was given in the totals, just that my equations are 55 rides and $2,000. Okay, so let's give an equation for the rides and let's give an equation for the money. Okay, so what rides were accepted? They were horse rides and elephant rides, and that added up to 55. And then now let's look at the money. So money-wise, the horse rides cost $20. The elephant rides cost $50. And $2,000 altogether was collected. Okay, so again, now that the numbers are getting higher, I'm still going to suggest, again, you are allowed to use substitution if you would like to, that we're using elimination to solve, just so we don't have to solve for a particular variable. So in order to eliminate, I'm going to go ahead and eliminate the very first variable here again. So in order to do so, I want my coefficient to be, I should have used pink and kept the same colors that I was using. I want the coefficients to match. So I'm going to do 20 times h, which is 20h. 20 times E, and then 20 times 55. Okay, I'm going to keep the bottom equation the same. And then we are going to do some subtracting. I'm going to move my face up there just so I have room to write. So subtracting, and I know that because if again, my goal is to eliminate. And if I add, I'm going to get 20 plus 20, which is 40. So we're going to go ahead and subtract those, which eliminates 20 minus 20 is 0. 20 minus 50 is negative 30. And 1,100 minus 2,000 is equal to negative 900. Then I need to divide on both sides. So my elephant rides, I'm starting to run out of room. If I do negative 900 divided by negative 30, gives me 30. So there were 30 elephant rides. Okay, now let's remember how many rides in all were there. There were 55 rides. So right here was our in all equation. Horse plus elephant is equal to 55. Elephant was 30. So now we need to figure out how many horse rides were given. So we're going to do 55. Again, I'm sorry if my writing is everywhere. Minus 30 to get our total. Okay, so 55 minus 30 is giving us 25. So there are 25 horse rides and 30 elephant rides. Okay, so I hope this video has helped you guys. I'm going to take it back to the very first slide so we can just review our steps. So that was that we read the problem, we determine what pieces of information is given, so what totals pretty much are given in your particular word problem, create an equation for each, state what your variables represent, and work to solve for the variables, either being solution or elimination, and you are able to choose that particular method. If you want to check out and try with substitution, take it back to one of my substitution videos for systems of equations to learn how to solve. Using substitution, my personal preference or my personal favorite, if I was solving it, would be elimination, but you are welcome to try substitution if you would like to. Just a quick note, remember I'm a private comment in Google Classroom away, or just an email if you need anything. Best of luck on today's assignment.